Assalamu alaikum everyone. This is Maruf Ahmed ID 12108003. My presentation topic is QuickSort. QuickSort is a sorting algorithm based on divide and conquer technique. This is one of the most efficient sorting algorithms. It selects a pivot value from an array and then divides the rest of the array elements into two sub-arrays, one on the right side of the pivot and the other on the left side. What is pivot element and partition process? QuickSort picks an element as pivot and then it performs partition of the given array around the picked pivot element. Partition process is the key process of QuickSort. Here is an algorithm and partition method of QuickSort. First, we perform QuickSort on an array and define its lower bound and upper bound. If lower bound is less than upper bound, we define a function p is equal to partition of the array lower bound and upper bound. We perform QuickSort on the array from lower bound to p minus 1 and then we again perform QuickSort to the array from p plus 1 to the upper bound. Here is an example of QuickSort. This is an array. We perform QuickSort on the array. First we pick the first element as the pivot. We select the first element as p, first element of the array as q. Increment p until the value of p is not greater than pivot element and decrement q until the value of q is not less than pivot element. Increment p until the value of p is not greater than pivot element and decrement q until the value of q is not less than pivot element. When p reaches to the element which is greater than the pivot element and q reaches to the element which is less than the pivot element, then swap them if p and q has not crossed each other. This is the new list after swapping p and q. Now again increment p and decrement q. Now we again increment p and decrement q according to the condition, but now p and q crossed each other, so just swap pivot element with q. Now the pivot element is in its right position. There are all element which are smaller than pivot element are on its left side and all greatest elements are its right side of pivot element. Now divide this array into two parts. One will contain elements which are smaller than the pivot and another will contain elements which are greater than pivot. Now perform these steps on each subarray until the single element remains in the subarray and then add them according to the given order to build a completely sorted array, and at the end we will get a sorted array like this. Time complexity of QuickSort: best case big O and log n, in average case big O and log n, in worst case big O n square. Applications of QuickSort: in commercial computing, information searching, cache friendly algorithm, numerical computations, and in scientific research. Thank you all.